Nobody told you the real story. They gave you the headlines, they gave you the press releases, they gave you the celebration. But what they never gave you, what they carefully avoided giving you, was the part that made grown engineers at NASA's Jet Propulsion Laboratory go completely silent in the middle of a briefing room. The part that made scientists who had spent their entire careers studying rocks and minerals and atmospheric data suddenly feel something they were completely unprepared to feel. What happened with Opportunity was not a space mission. It was something else entirely. It was a slow, accumulating revelation, one that kept getting bigger, stranger, and more unsettling the longer it went on. And it started before the rover even drove its first meter. There's a moment in the history of planetary exploration that does not get nearly enough attention. It happened in January 2004, in the early hours after a small six-wheeled machine named Opportunity bounced across the surface of Mars inside a cocoon of airbags and came to rest inside a shallow crater called Eagle. The engineers back on Earth exhaled. The landing had worked. The rover was alive. The mission clock had started. And according to every plan, every budget document, every engineering specification they had signed their names to, Opportunity had approximately 90 Martian days, roughly 92 Earth days, to do its work before the cold. And the dust and the math caught up with it. 3 months. That was the plan. That was what they had designed for, tested for, launched for. Nobody in that building believed the story was going to end any other way. Then Opportunity opened its eyes, and everything changed. Before the rover had even driven out of its landing crater, before it had traveled a single meaningful distance across Martian terrain, it looked at the ground around it and found something that the entire scientific community had been trying to confirm for decades. Scattered across the floor of Eagle Crater, mixed into the dusty reddish soil like something carelessly dropped from a great height, were hundreds of tiny round spheres. Dark, dense, almost perfectly formed balls, roughly the size of peppercorns, embedded in the rocky surface like blueberries pressed into muffin batter. The science team nicknamed them exactly that, blueberries. And to the untrained eye, they looked like nothing, just small rocks, just the kind of geological triviality you might expect on any barren planetary surface. But here is what most people watching from home did not understand. The mineral inside those spheres was hematite, and hematite of that specific spherical form at that specific scale does not form on its own. It does not precipitate out of volcanic activity. It does not crystallize from thin air. On Earth, the only process that creates hematite in that exact structure, in those exact quantities, scattered across a wide surface area like that, is water. Ancient water. Moving water. Water that once existed in volume and duration long enough to chemically transform the iron-rich rock beneath it. Opportunity had landed in a hole in the ground on another planet and immediately found proof that water had once been there. Not suggested it, not hinted at it, proven it. Think about what that means. The question of whether Mars once had water, a question that had driven decades of scientific debate, theoretical modeling, and orbital observation, was answered within weeks of Opportunity's first contact with the ground. The rover had not even moved yet, but here's where it gets stranger. Because finding blueberries was not supposed to be the headline. Blueberries were the opening act. What Opportunity found next, as it began to inch its way across the Martian surface toward nearby rock outcroppings, was something that pushed the implications further still. The rocks at a region the team called Guadalupe showed sulfates, specific mineral compounds that form when water and rock interact over sustained periods. They also showed microscopic, crystal-shaped voids, negative spaces in the rock matrix where crystals once grew before being dissolved away. On Earth, that kind of formation has a name. Geologists call it a mold, and it is the direct signature of evaporating mineral-rich water. Someone, something, some process had once soaked those rocks and then dried them out. The water had been there long enough to leave its chemical fingerprint behind and then disappear. And layered inside those same rock outcroppings was jarosite, a sulfate mineral so specific in its formation requirements that it had never before been confirmed on the Martian surface. Jarosite forms in acidic water, sulfuric acid level acidic, the kind of environment that would have been corrosive by human standards, certainly challenging for life as we understand it, but unambiguously, undeniably wet. Opportunity had found not just water, but chemically complex water. Water with a history. Water that had done things. The scientists did not celebrate quietly. Steve Squires, the principal investigator for the mission at Cornell University, put it plainly. From the very start, he said, Opportunity delivered on the search for evidence of water. And when you combined what Opportunity was finding with what its twin rover Spirit was discovering on the opposite side of the planet, carbonates, silica, hydrothermal signatures, the picture that emerged was not ambiguous. Ancient Mars was a radically different world from the frozen, airless desert it is today. It had been wet. It had been chemically active. It had been, in some measurable sense, alive in geological terms. An opportunity had only been on the surface for a few weeks. What the public narrative around this mission consistently underestimates is the compounding nature of the discovery timeline. This was not one breakthrough followed by years of quiet work. Every time opportunity drove somewhere new, something unexpected was waiting. When the rover ventured into its first significant crater, a wide depression called Endurance, the exposed cliff walls showed layered sedimentary rock, thin horizontal bands of material that had been deposited, sequentially, layer by layer, the way sediment deposits in a lake bed or a slow-moving river over thousands of years. Those layers told a story. They spoke of an environment where water had not just existed briefly, but had persisted, had accumulated, had cycled. The planet the scientists were uncovering bore almost no resemblance to the Mars the textbooks had described a generation earlier. But the engineers back at JPL were starting to face a different kind of challenge. By the time these discoveries were accumulating, Opportunity had already outlived its planned mission by a significant margin. And this is where the story of the science becomes inseparable from the story of the machine. Because what Opportunity did next, what it continued doing month after month, year after year, defied every reliability model they had built for it. The rover's solar panels, which were supposed to slowly choke with accumulated Martian dust until they could no longer generate enough electricity to keep the rover operational, were instead being periodically cleaned, not by engineers, not by any intervention from Earth, by wind. Martian dust devils, small vortexes of air that moved across the surface unpredictably, swept across the rover's panels and lifted the accumulated grime away, restoring power generation to levels the team had long stopped expecting. It was as though Mars itself had decided Opportunity deserved more time, that something on that planet wanted this particular story to continue. Read that again. A machine designed to live for 90 days was being kept alive, in part, by the atmosphere of another world. By 2005, Opportunity had set a one-day distance record on Mars, traveling 720 feet in a single driving session. By 2006, it was approaching Victoria Crater, a depression 8 times wider than Endurance, a geological library of exposed rock layers that would take nearly 2 years to fully investigate. By 2007, a severe regional dust storm hit Mars and drove the rover's solar panel output to its lowest levels ever recorded, just 128 watt-hours per day, compared to a normal operating range of 700. All science activities were suspended. The team held its breath. And then the storm cleared, and Opportunity came back to life and continued driving. Every threat to the mission resolved in Opportunity's favor. Every near-death became another chapter rather than an ending. The rover was developing what the engineering team could only describe as a stubborn, unreasonable refusal to quit. And the discoveries kept coming. In the later years of the mission, Opportunity drove toward the rim of a massive ancient impact scar called Endeavour Crater, a crater spanning 22 kilometers across, so large that its interior contained geological formations dating back to a period of Mars history that predated anything Opportunity had investigated before. When the rover finally reached the rim of Endeavour in 2011, 7 years into a mission that was supposed to last 3 months, it found something that genuinely surprised the scientists. Bright veins of a white mineral running through the dark rock like cracks filled with chalk. Those veins were gypsum, calcium sulfate, a mineral that on Earth forms specifically when liquid water moves through underground rock. Fractures in deposits dissolved minerals as it flows. These were not surface deposits. These were not atmospheric condensation effects. These were the fossilized traces of underground water movement, ancient hydrothermal activity, a Mars that had not just been wet on its surface, but potentially wet beneath it, with water moving through the rock itself like blood through veins. What most people are not seeing in this discovery, even now, is the implication it carries forward into the present, because those gypsum veins at Endeavour Crater suggested that the water history of Mars was not a single episode. It was not a brief window billions of years ago when conditions were briefly permissive. It was a layered, complex, long-duration hydrological story: surface water, atmospheric water, subsurface water. A planet that had been shaped by water repeatedly, in multiple forms, over geological timescales that dwarf anything in human comprehension. An Opportunity, this 400-pound machine that was supposed to live for 90 days, was the first instrument capable of getting close enough to touch that story with physical sensors. By the time the rover marked its 5,000th Martian day of operation in February 2018, a milestone so far beyond its design parameters that it seemed almost absurd, the science team was using it to investigate a place called Perseverance Valley, a channel, carved into the western rim of Endeavour Crater, that appeared to have been formed by flowing water or debris moving downhill in the ancient past. The rover's cameras were sending back images of terrain that told geological stories in every frame. The team was working on papers, they were writing analysis, they were making plans, the machine was still delivering. And then June 2018 arrived. And Mars did what Mars had always been capable of doing. A dust storm began forming near the rover's location in early June. This was not unusual. Mars experiences dust storms regularly, but this one did not stop growing. It expanded, it spread, it climbed into the upper atmosphere and wrapped itself around the entire planet. Within weeks, what had started as a local event became a planetary encircling dust event, a global storm that atmospheric scientists operating the Mars Reconnaissance Orbiter high above the surface watched engulf the red planet entirely. The storm raised enough particulate matter into the atmosphere to block the sun from reaching the surface. Not dim it, not reduce it, block it. NASA project manager John Callis later described what the rover's final data transmission showed them. The skies, he said, were incredibly dark, to the point where no sunlight gets through. It was nighttime during the day, on an entire planet. This is not dramatic language. This is what happened. Opportunity's solar panels, deprived of sunlight, lost the ability to charge the rover's batteries. The machine had a survival protocol for exactly this situation. When power dropped below critical thresholds, it would shut down non-essential systems and enter hibernation, drawing the absolute minimum power needed to keep its internal clock running and its heating elements barely functional, waiting for conditions to improve. It had done this before during previous storms. It had always come back. The team knew this. They were cautious, but they had reason to believe the rover would survive, as it always had. The storm, they hoped, would pass. The dust would settle. The sun would return. Opportunity would charge back up and call home. On June 10th, 2018, on the 5,111th Martian day of a 90-day mission, Opportunity sent its last transmission. It was not words. The rover did not speak in words. It sent data, atmospheric readings, power levels, camera data. What it communicated in the clinical language of instrument telemetry was that the storm was worsening, that the skies around Endeavour Crater were darkening toward total blackout, and that power was critically low. The final image the rover transmitted was an attempt to photograph the sun through its solar filter. What came back to Earth was a nearly black image, incomplete because the transmission ended before it could finish sending, interrupted by the dying of the machine's power reserves. The image showed almost nothing, just darkness, a noisy, fractured glimpse at a Martian sky so thick with dust that the sun had effectively ceased to exist. The engineers sent more than 1,000 recovery commands over the following months. They broadcast wake-up signals. They adjusted frequencies. They used every tool they had. NASA engineers played Opportunity a final wake-up song, Billie Holiday's I'll Be Seeing You, in what amounted to a farewell broadcast across 150 million miles of empty space. There was no response. On February 13th, 2019, NASA officially declared the Opportunity mission complete. The rover had operated for 5,498 Earth days. It had traveled 28.06 miles across the surface of another planet. It had exceeded its designed lifespan by 55 times. It had returned more than 217,000 images. It had found proof of ancient water, gypsum veins, acidic hydrothermal environments, layered sedimentary deposits, and mineral formations that had collectively rewritten the scientific understanding of Martian history. It rested finally in a place called Perseverance Valley. Even the geography chose its words carefully. A journalist named Jacob Margolis, discussing the rover's final transmission with NASA scientists, later described it in terms that traveled around the internet in a way that pure technical data never could. The rover's last message, he wrote, basically translated as, "My battery is low and it's getting dark." The phrase was not a verbatim transmission. The rover did not speak in sentences. But the engineers who heard Margolis describe it did not correct him harshly, because the translation was, in the most important sense, accurate. A machine 150 million miles from the nearest human being, alone on a planet being swallowed by a storm it could not survive, sent a final message that said power was failing and the sky was going dark. And then it went silent. What matters now, what the legacy of Opportunity means in the context of everything that has happened since, is that the rover did not just find data, it changed the direction of an entire field of science. The questions it answered in 2004 about ancient water created the framework for the missions that followed it. Curiosity, which landed in 2012 and is still operating today, was built to go further, not just to find water evidence, but to assess habitability, to measure organic chemistry, to ask whether Mars could have supported microbial life. And in 2024, Curiosity accidentally ran over a rock in an ancient waterway called Geddes Vallis and cracked it open, revealing bright yellow crystals of pure elemental sulfur, the first pure sulfur ever found on the Martian surface, in a form that had no obvious explanation and immediately required scientists to reconsider what they understood about the planet's geological chemistry. The project scientist called it like finding an oasis in the desert, something that should not be there, something that now demands to be explained. And Perseverance, the most sophisticated rover ever sent to Mars, landed in Jezero Crater in February 2021 and has been building on Opportunity's foundational discoveries ever since. In July 2024, Perseverance reached an ancient river valley called Neretva Vallis and found a rock that stopped the entire science team cold. A 3.2-foot rock nicknamed Chayava Falls, covered in unusual leopard spot patterns and poppy seed-like formations that bore a startling resemblance to textures produced by microbial metabolism on Earth. The rover drilled a core sample, named Sapphire Canyon, and trained every instrument it had on the chemistry inside it. What it found, after a year-long peer review process published in the journal Nature in September 2025, were minerals including vivianite, graphite, organic carbon, sulfur, oxidized iron, and phosphorus. On Earth, vivianite is found in peat bogs and around decomposing organic matter. Greygate can be produced by microbial activity. The combination, according to the lead scientist Joel Hurowitz of Stony Brook University, mirrors what we see in sediment on Earth, where ancient microbial communities have left their chemical signatures behind. NASA's acting administrator called it the closest humanity has ever come to discovering life on Mars. The word potential, biosignature, entered the official scientific record. Not confirmed life, not definitive proof, but the closest thing to a positive signal the history of planetary science has ever produced. And none of that story exists without Opportunity, without the blueberries in Eagle Crater in 2004, without the gypsum veins at Endeavour in 2011, without the 14 years of data that built the case, layer by layer, that Mars was not always what it is today, that something happened there a long time ago in water, in chemistry, in conditions that once made life at least theoretically possible. Here is what you need to sit with. We sent a machine to another planet, expecting it to survive 3 months. It survived 15 years. In those 15 years, it rewrote the scientific understanding of Mars so completely that the mission which followed it was specifically designed to look for signs of life. Not just water, not just habitability, but life. And that mission, in 2024, found the closest thing to a positive result the search for extraterrestrial life has ever produced. The chain is unbroken. Every discovery connects to the one before it, and it all traces back to a rover that opened its cameras on the floor of a shallow Martian crater and found tiny round spheres of hematite that told a story nobody on Earth had fully prepared themselves to hear. The question that nobody can answer right now is what comes next. The Sapphire Canyon sample is sitting in a titanium tube on the surface of Mars, waiting. The Mars Sample Return mission, the operation that would physically bring Martian material to Earth for laboratory analysis, has been debated, budgeted, redesigned, and debated again. As of now, no firm launch date exists. The sample with a potential biosignature is on another planet. The technology to retrieve it is not yet in motion. And the clock, in some sense that nobody wants to say out loud, is ticking. Not just for budgets and political will, but for the question itself. The biggest question in the history of science, are we alone in the universe, is waiting on a rock in a river valley on Mars while we figure out the logistics. Opportunity spent 15 years telling us Mars was worth looking at this closely. It turned out to be right. The question is whether we are willing to take the next step that its discoveries made possible. Whether we are going to reach across 150 million miles of space and pick up the answer it spent its life helping us find. And whether, when that answer finally arrives, we are ready for what it might say. Because there is a real possibility, not certain, not confirmed, but real, that Opportunity's greatest discovery was not what it found on Mars. It was what it proved was possible, that a world we thought was dead was not always dead, that the universe is stranger, wetter, older, and more generous with the conditions for life than we had any right to expect, and that somewhere on a red planet in a valley carved by ancient water, the evidence we have been looking for since the first human looked up at the sky and wondered is quietly waiting for us to come and get it.